translate these. So words that mean addition, you're looking at more than, and that's the one where everybody wants to use the more than symbol. So just make sure you're aware of what you're trying to do here. I'm trying to translate this into an expression. An expression has terms and operation symbols. So addition, subtraction, multiplication, division. So in this case, more than is not the more than symbol, it's the addition symbol. Which means if I were to translate this first one, you want 6 more than a number. Remembering that a number is just your variable. That's how they represent the unknown. So if I want 6 more than a number, you could write it as 6 plus x, or you could write it as x plus 6. The order in which you add doesn't matter, so you could write it either way. Increase by is another way to talk about addition. So a number increased by 8 is still an addition expression. Added to, of course, is addition. So 5 added to a number, so 5 plus x or x plus 5, either way would be accurate. And then the sum. The sum is the answer to an addition problem. So the sum of a number and 17 would mean x plus 17. Or if you wanted, you could write it as 17 plus x. So the words that mean to add. Usually the addition words aren't the tricky ones. There is one tricky one in subtraction that I tend to recognize a lot of people will flip backwards. 18 decreased by a number. Decreased by a subtraction. So you're taking 18 and you're decreasing that number by a number. And this second one is the one that everybody gets backwards. If I want 6.5 less than a number, then I want to take the number and I want 6.5 less than that. So if I were to say that there was ever a tricky one in this, or the one that people get backwards the most, it's this one, less than. It's not the less than symbol, but it does mean that you're taking whatever that number is and you're subtracting 6.5 from it, not the other way around. The next one is kind of the same idea, 3 subtracted from a number. 3 subtracted from a number, which means you're taking the number and subtracting 3 from it. So just making sure we've got our subtraction in the correct order. And then difference, probably the most common one, the difference between a number and 5. And when they say it like that, you write it in that order. So the difference between a number and 5, x minus 5. Questions on addition and subtraction. Okay, multiplication. Times, of course, just means to multiply. So 8 times a number would just be 8x. Now, I will say this, because we are translating, lots of people like to get into writing something like this when we are in algebra. I would not expect to see it written that way from you guys. We know that we can take a number and put it with a variable and it's still multiplication. You could write it with the dot, but I would not expect you to write it with 2 x's because that's just way too confusing. What does it mean to take twice of something? Multiply by 2. A number multiplied by 4. Product is the answer to a multiplication problem. So a product of a number and 19. And then 2/3 of a number. This is the one that some people tend to forget. Of means to multiply. So if you think about, you want half of something. We're multiplying it by 1/2. It goes back to percentages and figuring percentages. If I want 6% of a number, I'm taking 0.06 and multiplying it by whatever that number is. So of means to multiply. So 2/3 of a number could be represented as 2/3 times x. Division is pretty straightforward. The only other thing from division that you have to be careful of is the order in which you write it, kind of like subtraction. So order doesn't matter in addition and multiplication, but it does matter in subtraction and division. So a number divided by 5. Now, when you go to solve these, it's going to be easier for you to write them as ratios rather than to write it like this, just because of the way that we're used to seeing equations set up. It doesn't make this one incorrect. It wouldn't be incorrect in the solving equations. It's just easier to look at in terms of solving for you guys if you use them as ratios. So 35 divided by a number, so 35 divided by x. And then the quotient is the answer of a division problem, and it goes in order, just like the difference, excuse me, for subtraction goes in order. So the quotient of a number and 6 would be a number divided by 6. So divided by, quotient, those are your words that mean to divide. Now, all of this is review, which gets us into translating equations so that we can solve for those, which gets us into then applying that to the application type problems, which is the main portion of this first section. So solving translation problems. First thing we're going to do is translate it, and then we're going to solve it, the equation. So remembering that is where your equal sign goes. So we talked about all these words that mean to add, subtract, multiply, and divide. Is where your equal sign goes. So if I look at this first translation, I want 8 times a number plus 3. So I want 8 times a number plus 3 is 27. And then we can solve that. A couple different ways to solve it. You can what's the word I'm looking for? Distribute it. So if you distribute it, you would get, you still see what I'm writing, 8x plus 24, right? Subtract 24, and that would get you 3, which means your answers would be 3/8. $10 less than twice a number. What's twice a number? 2x, and then I want 10 less than that. So I'm going to subtract 10 from that. So remember, when you see that less than term, it's usually the one that gets flipped backwards. So just be careful in the order in which you're writing that. There's your is, which is your equal sign. So first thing I do, add 10, which would give you 52, and then 52 divided by 2 would give us 26. So just being able to take those words, translate it, put it into an equation, and solve it. So what we're going to do is kind of take all those ideas down here to application, and then write an equation based off of the application and solve it to answer the question. So the first one, 2 basketball teams. By the way, I typed this up really quickly this morning, so if there's any typos, let me know so I can fix it, because I'm sure there is. 2 basketball teams are interested in signing a free agent player. An inside source informs the general manager of one team that the other has made an offer, and the player's agent said, double that and add an extra $1 million per year, and you're in our league. According to a published report, the player is seeking a contract of $18 million per year. What is the rival team's offer? So what you want to do is pick out, in any story problem, the relevant information. So relevant information, first thing I know is twice the offer plus 1 million should be close to 18 million, because that's where he wants to be. So this is what he told him to do, right? Double that, which is twice that. And we're just going to say 2x, because that is what we don't know. Add an extra $1 million. And you want it to be somewhere close to 18 million. Is what he's saying. So we use the variable x to represent the offer. You can use any variable you want. Since the members are in the millions, we'll let x stand for the offer in millions dollars of units, which is what we're finding. And then basically you're just solving that equation. So if you take, I didn't bring my calculator over here, but if you take 2x, right, and you subtract 1 million from 18 million, you're going to get 17 million. And then 17 million divided by 2 would be 8.5 million. Okay. So to answer the question, the team's offer, the first team's offer was 8.5 million, right? According to the published, what was the rival team's offer? It was 8.5 million. Which in this case would be an insult if you're looking for 18 million. Sure, less than half that. So one of the things that you do, again, and I'm going to put like the strategies for solving story problems in when I put this on classroom. But one of the things is pulling out the relevant information and using it to create your equation in order to answer the problem. Questions on that one? Flip the page. A teacher with a fondness for joking around with students tells one that if he doubled his score, so doubling a score is multiplied by 2, on his last test, and we don't know what his last test is, so we're going to use that as X, and subtract 12%, he would have just barely gotten an A. The syllabus says that the minimum cutoff for an A is 92%. What is the student's score? So we take his last test. She tells us to double it, right? And then we want to subtract from that 12% of whatever this is. So how do I find percent of something? What did you say? You multiply. So then I'm going to subtract from that whatever 2x was, right, times 0.12%. You want to turn your percent into a decimal. So take whatever this is. I want to subtract 12% of whatever that is. And that has to be barely gotten an A, and an A is at 92%. So that's got to be equal to at least 0.92. I don't have my calculator here. So one of the things when you're working with these, just remember with percent to convert those into decimals so that you're not using too many place values. All right, so first thing I'm going to do is take 0.12 times 2, because what that gives me is 2x minus 0.24x. So I multiply these two together. Now I have like terms, so I'm going to subtract those like terms, which gets me 1.76x is equal to 0.92. Oops. Divide that out. And you get 0.534, which means that his last test score was 53%. Questions on how I set that up? So pulling out the relevant information. One of the things that I do when I go through here and talk is make myself little notes that tells me what it's saying and what I'm going to use to represent that. So doubled was times 2. Last test is what I'm trying to find, so that's my variable. Subtract 12% of that. So then remembering your rules for solving equations. Okay, Pat and Ron are planning to build a deck at the back of their house, and they buy some plans from the internet. The plans can be customized to the required deck height, which in this case will be 92 inches. They called for support posts of 2 different heights. The taller ones are 8 inches longer than the shorter ones. Now, the very first thing I would tell you to do is anytime you get to a sentence that bases one thing off of another. So I am basing the taller ones off of the value of the shorter ones, then write equations for those or expressions. So if I make the shorter ones equal to x, then I know that the larger ones are going to be 8 inches longer than the shorter ones. So I could represent the longer ones by 8x plus 8 or 8 plus x, however you want to do it. All right, and the plan says that the sum of heights should be the height of the deck. How long should the support posts, be cut? So in this case, the height of the deck is 92 inches. So what they're saying is if we translate the information. So if we add the shorter posts to the longer posts, then they should be equal to how tall or height of the deck. So you're taking the shorter post, you're adding them to the longer post, and they need to be equal to the height of the deck. I'm going to say that one more time. Anytime in a story problem you have 2 items that are based off of each other, then you're going to have to write an expression for both. I have 5 more dimes than I do nickels. I have twice the amount plus 5 acres as I do horses. I don't know. But you've got to base one off of the other. Okay, so first thing I'm going to do is combine like terms. Subtract 8. Divide by 2. And we get 42. Okay, so we haven't necessarily answered the question, so you got to go back and reread. We were asked to find 2 lengths, so x is 42 isn't just a valid answer. We need to use x to represent the length of the shorter post. So I know that the shorter posts are 42, and it's just asking you to go back then and tell what the longer posts are, because it was a second question. So then if I take 42 plus 8, the value of my big post then would be 50 inches. Questions on that? Okay, I'm just going to keep going then. After a busy Friday evening, the tip jar at the off-campus, there's a typo, bagar, is stuffed full of dollar bills and quarters. The tradition is that the bartender split the dollars while the barback split the quarters. There's $245 in the jar with 3 times as many quarters as dollars. So here's again where we have based one item off of another, right? So if I take, we have 3 times as many quarters as dollars. So if I let X represent the amount of dollars we have, right? Then to represent the, I can spell quarters right, the quarters, we have 3 times as many quarters as we do dollars. So that's part of that translation. How much money goes to the bartenders and how much goes to the barbacks? So then we have to take into consideration how much each one is worth. So these are worth $1, which means we don't really have to do much with it, but I do need to multiply this by what to get its worth? What's a quarter worth? 0.25. Okay, so if I were to put this into an equation, then I've got 0.25 that I'm multiplying by how many quarters I have. So the value times how many you have, which we're going to do the same for dollars. It just happens that $1 is worth 1. So you can write it as 1 times how many dollars you have, but the 1 is implied, so it doesn't necessarily have to be there. So if I take the value, and here's kind of where words help you out. If I take the value of the quarters and add it to the value of the dollars, that has to be equal to the total amount of money that was in the jar. So one of the ways, again, to get through these is to kind of talk your way through it. One kind of hint I will give you is anytime you're doing a story problem with money, quarters, dimes, nickels, and they're talking about the value versus the amount or the quantity, it usually sets up like this, where you're going to have the value times the quantity is going to equal your total. Almost all the time when you're talking about money, the value of whatever the money is times the quantity of how many of those you have is going to equal the total amount. So then if I solve this, you are multiplying then the front part. Oops. So you get 0.75x plus 1x is equal to 245. Combine like terms. Combine like terms, and then 245 divided by 1.75 is 140. Now remember, we had x represent dollars. So she has 100, or they have $140 in dollar bills, but they started off with 245. So, 245, I can't type, 245 minus 100. So that means they have $105 in quarters and then 140 in dollar bills. And I think that answers both questions. How much money goes to the bartenders and how much goes to the barbacks? So 140 goes to the bartenders, 105 goes to the barbacks. Does everybody know what a barback is? It's the people that help you behind the bar. So like if I'm bartending, it's the people that go get your extra cases of beer that you need or refill your ice stuff. Go get you another keg because you ran out. They're your secretaries as a bar. They do everything that in the back. Clean, clear tables.
You said one time you were a bartender?
Yeah, but I never had a bar back. I did it all myself.
There you
Okay, so your I wouldn't say that. I just didn't like a lot of people in my way.
Historical